Hello everyone, in this video we're going to review the topic 1.7 to 1.11 about the rational functions. Alright, directions. For each of the following rational functions, write the limit statements to describe the left and right end behaviors. Alright, so on the x and y coordinate, you always put the positive infinitive right here, negative infinitive right here, positive infinitive and negative infinitive. Alright, so left end behavior, which means limit of the function f of s when s approaches negative infinity, right? S approaches negative infinity, which means it's go to the left right here. The function approaches the horizontal asymptote, which is 1, right? So horizontal asymptote y equals 1, right? So this one equals 1. Right end behavior, limit of the function f of s when s approaches positive infinity is going to be 1, right? When s approaches positive infinity, the function approaches horizontal asymptote, which means 1, right? Now, number 2, limit of the function f of s when s approaches negative infinity equals 2. Because the horizontal asymptote is 2. You see the dashed line here, right? This one is y equals 2, right? So this one is 2. Limit of the function f of s when s approaches positive infinity is still 2, right? Now let's move on to question 3. Given the function, we need to find the end behaviors. Alright, so look at the highest degree terms on the numerators and denominators, right? Which means this guy right here. Alright, limit of the function h of s when s approaches negative infinity equals 2 over 3, right? Because y equals 2 over 3 is the horizontal asymptote, right? When degree on the numerator and degree on the denominator are the same. And then you just cancel out this one. So the horizontal asymptote is 2/3, right? Now, limit of the function h of s when s approaches positive infinity is going to be 2/3, right? Similarly, number 4 right here, you look at this one right here. Degree on the numerator is 2, right? This is power 1, this is power 1. So total is going to be power 2, right? Degree on the denominator should be, this is power 2, right? And this is power 1, right? So total is going to be s power 3, right? Because the degree on the numerator is 1 less than the degree on the denominator. So then the function has the horizontal asymptote y equals 0, right? So keep that in mind. So limit of the function k of s when s approaches infinity equals 0. Limit of the function k of s when s approaches negative infinity is still 0. Alright. Now look at number 5 right here. The highest degree on the numerator is s power 4, right? The highest degree on the denominator is going to be s power 2, right? So in order to find the end behavior of this one, you just ignore the rest one right here. Because this one is dominating the whole thing, right? So you have negative 2 s power 4 over 5 s power 2. And you just simplify, it's going to be negative 2 over 5 s squared, right? So limit of the function rs when s approaches positive infinity is negative infinity, right? Because positive infinity, you substitute over here, it's going to be positive infinity multiplied by negative 2 fifth is still negative infinity, right? Now limit of the function Rs when s approaches negative infinity. This guy becomes positive infinity, right? Multiplied by negative 2/5 is still negative infinity, right? Now let's move on to number 6. We need to rewrite the function m of s as 3. This is coefficient. You need to rewrite it, right? Now s minus 1 square. This one dominate the whole thing, right? So it can be s square. You need to check this one with s, right? Now s plus 5. When s approaches infinity, this one dominates, right? So it can be times s over this one right here. You have 2s right here, dominate 3, right? So you have 2s, don't forget parentheses, power up 2 right here. Alright, now you simplify, it could be 3s squared times s over 4s squared, right? Now s squared and s squared right here cancel out, so it's going to be 3 over 4s, right? Now limit of the function m s when s approaches positive infinity, it's going to be positive infinity, right? Because positive infinity multiplied by 3, 4 is going to be positive infinity. Now limit of the function m s when s approaches negative infinity, it's going to be negative infinity, right? Now let's move on to number 7 and number 8. Write a limit statement describing the output values for the following graphs and verbal description of the input values. Alright, the input values decrease without power, which means it's go to negative infinity, right? So the limit statement is going to be limit of the function f of s when s approaches negative infinity, right? So negative infinity should be right here, right? This one should be positive infinity. This one should be positive infinity, and this one should be negative infinity. So when s approaches negative infinity, the function going down like this, right? So it's going to be negative infinity, right? Now, for the number 8, the input values increase without bound, which means it's gonna go to positive infinity, right? S value go to positive infinity. So you have limit of the function g of s when s approaches positive infinity. Alright, so this is positive infinity. This one is positive infinity, this one is negative infinity, this one is negative infinity, right? So we just focus on this guy only, right? S approaches positive infinity, the function approaches horizontal asymptote, which is y equals 1, right? So it's gonna be 1, right? Now let's move on to number 9, 10, 11, 12, 13, 14, 15, and 16. The graphs of the function h and k are given below. Use the graphs to find the following limits. Now, number 9. Limit of the function h of s when s approaches 2 minus, right? Now, first you need to label positive infinity, negative infinity, and negative infinity. When s approaches 2 minus, look at 2 right here. This is the vertical asymptote, which is s equals 2, right? 2 minus, which means on the left of the vertical asymptote. So on the left of the vertical asymptote, which means this guy right here, right? So the function approaches negative infinity, right? So this one is negative infinity. Now, number 10. Limit of the function h of s when s approaches 2 plus, right? So 2 plus, which means on the right hand side of the vertical asymptote, which is this guy right here, right? So it's going to be positive infinity right here. Number 11. Limit of the function h of s when s approaches 3 minus, right? 3 minus, this could be right here, which is we have the whole right here, right? Now 3 minus, which means on the left of the whole, right? So the function approaches 3, right? Because the y value is 3, right? It's going to be 3. Now limit of the function h of s when h approaches 3 plus, which is on the right of the whole, right? It's still 3, right? So it could be 3. Now, number 13, you need to put positive infinitive, negative infinitive, and negative infinitive right here. Now, limit of the function k of s when s approaches 5 minus, right? So 5 minus is going to be right here, the whole right here, right? So 5 minus is going to be on the left of the wholes, right? It's going to be negative 2 right here, right? Now, limit of the function k of s when h approaches 3 plus, right? 3, which means the vertical asymptote right here, right? This is s equals 3. 3 plus, which means on the right of the vertical asymptote, which is this guy right here. The function approaches positive infinitive, right? Now, limit of the function k of s when h approaches negative infinitive, right? Negative infinitive, which means s go to the left right here. The function go up, right? So it's still positive infinitive, right? Now, limit of the function k of s when h approaches positive infinitive, right? So s go to the right, right? The function is going down. It's going to be negative infinitive, right? Now let's move on to number 17, 18, and 19. For each of the following, write the left and right limit statements for f of s as s approaches 1, right? Now left and behavior is going to be limit of the function f of s when s approaches 1 minus, right? Since number 17 right here, we have the common factor on the numerator and denominator. So this one is the whole, right? I need to cancel out this one. So then I just substitute 1 for s into the remaining one right here. So I have 1 plus 5 is going to be 6. 1 plus 2 is going to be 3. So the answer must be 2, right? Now, limit of the function f of s when s approaches 1 plus. It's going to be same thing. 6 over 3 is going to be 2. Alright, now keep in mind, limit of the function when s approaches 1 minus, it doesn't mean that s equals negative 1. So you need to get rid of that mistake. Alright, 1 minus, which means on the left of 1. Now number 18. Limit of the function f of s when s approaches 1 minus. Now you just substitute 1 minus for s in this situation. Again, 1 minus, it doesn't mean that negative 1. So keep that in mind. So I substitute 1 over here. It's going to be 1 minus 2. It's going to be negative 1, right? Times 1 minus 4. It's going to be negative 3, right? The bottom right here. I substitute 1 minus over here. So 1 minus right here, subtract 1. 1 minus, which means a number less than 1, right? So when you subtract 1, it's going to be 0 minus, right? Times 1 plus 2 is going to be 3, right? Now, the top should be 3. The bottom should be 0 minus, because 0 minus times 3, it could be 0 minus, right? 3 divided by 0 minus, it could be negative infinitive. So keep that in mind. Now, right, it's going to be limit of the function f of s when s approaches 1 plus. It's going to be 1 minus 2 times 1 minus 4 over 1 plus subtract 1 is going to be 0 plus times 1 plus 2. Alright, so the top should be negative 1 times negative 3 is going to be 3. The bottom should be 0 plus. So the answer must be positive infinitive, right? Now, number 19 right here. limit of the function f of s when s approaches 1 minus, it's going to be negative 2 times 1 plus 3 times 1 plus 1. Now the bottom right here, 1 minus subtract 1, it's going to be 0 minus, right? The top should be negative 2 times 4 times 2. It's going to be negative 16, right? Now the bottom right here, when you square 0 minus, it's still 0, right? It's positive 0. So the answer right here must be negative infinity, right? Now, limit of the function f of s when s approaches 1 plus, it's going to be negative 2 times 1 plus 3 is going to be 4. 1 plus 1 is going to be 2 over 1 plus subtract 1 is going to be 0 plus square, right? So the top should be negative 16, right? The bottom right here should be 0 plus, right? So the answer must be negative infinity, right? Now, let's take a look at the number 20, 21, and 22. For each of the following rational functions, determine and label any values of s where the graph has a hole or vertical asymptote, right? Now, keep in mind, the vertical asymptote is when denominator equals 0, right? The hole is when the numerator and denominator have the same common factor, right? Now, first we need to find a hole. S minus 2 and S minus 2 cancel out. This is a common factor. So the hole should be S minus 2 equals 0, right? So then S equals 2, right? Now, S plus 3 and S plus 3 right here cancel out. And again, this is not a hole. Keep in mind, the vertical asymptote dominates the hole. The hole dominates 0. Now, I need to cancel out S plus 3 and S plus 3 right here. So the final answer must be 1 over S plus 3. Alright, so the vertical asymptote is S plus 3 equals 0. And then S equals negative 3. S equals negative 3 is the vertical asymptote. It's not a hole, right? Keep in mind, vertical asymptote dominate the hole. Alright, if this guy and this guy occur at the same time, the vertical asymptote dominate, right? Now, number 21, you need to simplify this one. So I have S plus 7 over S plus 1, right? Now this guy cancel out this one, right? So I have S plus 2 left on the top, right? Now, the whole is S plus 2 equals 0. So then S equals negative 2, right? Because you just cancel out the numerator and denominator with the common factor, right? After you cancel out the common factor right here, you still have one factor on the numerator. So this one will be a 0, right? And you know that the whole dominates the 0, right? So this one is not a 0, right? Now, the vertical asymptote, you just let denominator equals 0. So you have S plus 1 equals 0. So S equals negative 1, right? Alright, number 22. You need to factor S squared out first, right? So I have S squared times S minus 1, right? Denominator, this is a complete square, right? It's going to be S plus 1 altogether square. Look at the numerator and denominator. You don't see any common factor, right? So there is no hole for in this situation, right? Now the vertical asymptote, just let denominator equals 0, right? So S plus 1 equals 0. and then s equals -1, right? Now let's move on to number 23, 24, 25, and 26. We need to solve the inequalities, alright? And write the answer in interval notation. Alright, now to solve the rational inequalities, you need to find the zero of the numerator and denominator, right? So first, I have s minus 3 equals 0. And then I have s equals 3, right? Second, s plus 2 equals 0. And then s equals -2, right? Now, I need to put this guy on the number line. Alright. -2 less than 3, so I put -2 right here and 3 here. Alright. Right at these two guys right here, I have the 0, right? So I put 0 here, 0 here, right? Because these two guys right here are 0 of this factor, right? Now, you need to pick a number within any interval, right? So within interval -2 and 3, I pick a 0, right? I substitute 0 for s into original 1 right here. So I'm gonna test, right? So I have 0 minus 3 over 0 plus 2. Now 0 minus 3 is going to be -3, right? So 0 plus 2 is going to be 2. This guy actually negative, right? So negative, I put negative side right here. I need to check each of these factors right here to see if there is any even multiplicity, right? So I don't see any even multiplicity, right? Because this one right here, power up 1. This guy right here, power up 1, right? Right? So I keep changing the sign, right? This is negative. This guy must be positive. This guy negative. This guy must be positive, right? Now, I need to write the solution. I need this guy to be less than or equals 0, right? So my solution should be from here to here, right? Since this one has the equal sign, I need to include the 0 of the numerator, right? Don't include the 0 of the denominator, so keep that in mind. So my solution should be from -2 to 3 right here, right? So I put -2, comma 3. Now, -2 is the 0 of denominator, so this guy must be parenthesis, right? 3 is the 0 of the numerator, so this guy must be bracket. Now let's move on number 24. The 0 of s minus 1 square is going to be s minus 1 equals 0. So it's going to be s equals 1, right? Now s plus 2 equals 0. Then s equals -2, right? Now s plus 1 equals 0. Then s equals -1, right? Now I need to put all of this guy on the number line, right? So I need to place -2 first. Next one, -1, right? And the last one should be 1, right? On the right hand side right here, I put positive infinitive. The left hand side right here, I put negative infinitive, right? Now I need to put 0 for the numerator. So the numerator, I have the 0 right here. S equals 1 right here, right? So right here, I put 0. Now, s plus 2 is going to be -2 right here. This one still 0. On the denominator right here, s minus 1, so I put a line right here. Because s equals -1 make the whole thing undefined, right? Now I need to pick a values within any interval, right? So I pick 0 right here in this interval right here. I substitute 0 for s into this inequality right here. I need to check to see if it's positive or negative, right? So it's going to be 0 minus 1 is going to be -1. -1 squared is going to be 1, right? Times 0 plus 2 is going to be 2, so times 2 over 0 plus 1 is going to be 1, right? So this guy is positive, right? Now, this interval is positive. you need to be careful with the 0 right here, s equal 1 right here. So s equal 1 is going to be this guy right here. Alright, because s equal 1 right here is the 0 of this one, but this one has the even multiplicity. So, right at this one, you don't change the sign, you keep the sign. Now, this is the plus side right here, this one is still the same, plus side, don't change it, right? Now, this 0 right here has the odd multiplicity, right? Negative 1 right here, which means on the bottom right here, you keep changing the sign, right? So this is positive, this guy must be negative, right? S equal negative 2 right here is the 0 of this one right here, right? It's still odd multiplicity, right? So keep changing the sign. Alright, now finally, you look at this one right here. You need this guy to be greater than 0, right? So your solution should be this interval right here and this interval right here, right? So I need to write the solution in the interval notation. So it could be negative infinity to negative 2, right? So negative infinity, right at this negative infinity, you need to put parentheses, no bracket, okay? Comma, negative 2. Now, look at this one, I don't see equal sign, so this one must be parentheses. Alright? Union. Now, right here, you need to be careful. You're not going to include the 0 right here. 1. Why? Because you don't have the equal sign. Right? So you need to exclude this one, right? So you need to write the interval from negative 1 to 1. Union, the interval from 1 to infinity. Alright, so keep that in mind. Now let's move on to number 25. You need to factor the numerator, right? So the numerator I have a equals 1, b equals negative 1, c equals negative 12. So I need to use S method. Now you need to find two integers that multiply equals negative 12, add up to negative 1 right here. So it's going to be negative 4 and 3, right? So the numerator can be factored as minus 4 times s plus 3 over s squared greater than or equals 0, right? Now you need to find the 0 of each of these factors, right? So I have s minus 4 equals 0, s equals 4, right? S plus 3 equals 0, s equals negative 3, right? Now, s squared equals 0, s equals 0, right? This one is multiplicity of 2, right? So be careful on this 2 right here. Alright, so you need to place all of this one on the number line, right? The left hand side is negative infinity, the right hand side is positive infinity, right? So it could be negative 3 go first, 0 next, and next one is going to be 4, right? Alright. The 0 on the numerator is going to be 4 and negative 3, right? So it could be right here. The 0 on the denominator is going to be 0, right? So on the denominator, I'm going to put a line. Because this makes the whole thing undefined, right? Now, I need to pick a number within any interval right here. So, I'm going to pick number 1 right here, right? I substitute into this expression right here to see if it's positive or negative, right? 1 minus 4 is going to be negative 3, right? 1 plus 3 is going to be 4. Negative 3 times 4 is going to be negative 12, right? 1 squared is going to be 1. So this guy should be negative, right? So this guy should be negative side right here, right? Now, I keep changing the sign. If I don't see the 0 with the multiplicity of 2, right? Now, write at 0 right here. It's going to be right here. Multiplicity of 2. So I don't change the sign. I keep the sign. So this negative, this still negative, right? Negative 3 right here. This is multiplicity of 1, right? So I just change the sign, positive. Right at 4 right here, multiplicity of 1, right? I just change the sign, negative, and then this guy positive, right? Now finally, I need the whole thing greater than or equals 0, right? Which means this guy all the way to the left, right? This guy all the way to the right, right? So I need to write the final answer should be negative infinity, comma, negative 3, right? Because I have the equal sign right here, and negative 3 is the 0 of the numerator, so I need to include the bracket, right? Union, same thing. I need to include 4, right? Because 4 is the 0 on the numerator, right? Comma, positive infinity, right? Now let's move on to number 26. I need to find the 0 of each of this one, right? So I have negative 2s equals 0, and then s equals 0, right? Next one, s minus 3 square equals 0, and then you need s minus 3 equals 0, and then you have s equals 3, right? This one multiplicity of 2, right? So be careful. Now next one, you have s plus 2 equals 0, and then s equals negative 2. This is multiplicity of 1, right? Now the last one, s minus 4 square equals 0, and then s equals 4, right? This one multiplicity of 2, right? Alright, now I need to put all of this guy on the number line. On the left hand side, negative infinity. The right hand side is positive infinity. Now, the first 0 is going to be this guy. The second 0 is going to be this guy. The third one is going to be this guy. And the last one is going to be this guy, right? So I'm going to start from negative 2 first. The next one should be 0. The next one should be 3. And the last one should be 4, right? Now, which one is the 0 of the numerator? It's going to be 0 right here, right? So I put 0 right here. S equals 3 is the 0 of the numerator, so it could be right here, right? This one right here, I put a line because it makes the whole thing undefined, right? Alright, now I'm going to pick a number within any interval and I'm going to test for the sign of the inequality, right? Now I'm going to pick 1 within interval 0, 3 right here, substitute over here. So I have 1 times negative 2 is going to be negative 2. 1 minus 3 is going to be negative 2 square is going to be 4. 1 plus 2 is going to be 3. 1 minus 4 is going to be negative 3 square is going to be 9. So the whole thing right here should be negative, right? Because negative times 4, positive times 9 right here. So this will be negative, right? So within this interval, I put the negative sign, right? Now I need to check for the even multiplicity, right? Right at 3 right here. This is the even multiplicity right here. Do you see that? Alright. So right here, I don't change the sign. I need to put the negative sign, right? Now I check 4 right here. 4 is still even multiplicity right here, 2. So it's still negative, right? Now I check 0 right here. This is odd multiplicity, right? I need to change the sign, positive. Now I check negative 2 right here. It's odd multiplicity, right? So I need to change the sign, alright? Now finally, I need the whole thing to be less than 0, right? So I pick the one with negative sign, right? So it's going to be right here. And it's going to be right here, right? Now be careful, you're not going to include the 0, right? Because you don't have the equal sign right here, right? So they are parentheses, so keep that in mind. Now it's going to be negative infinity 2, negative 2, parentheses, union, 0, 2, 3, right? Union, 3, 2, 4, union, 4, 2, positive infinity. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun. as she puts her hand in mine.